Everyone, welcome to Cassandra Lunch number 92. Couple more, what was it, 2 months left till we hit the big 100. Today's topic is going to be an extension of a previous Cassandra Lunch. So if you missed the first talk on securing Apache Cassandra, be sure to check it out. You can find it on our YouTube channel, youtube.com/AnantCorp. You can also find it on the Cassandra Lunch playlist. And today's extension talk is going to be on managing roles and permissions. And the talk's going to be also, again, given by Rahul Singh, CEO at Anant, as well as a business platform architect. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk either at Cassandra Lunch or Data Engineers Lunch, feel free to reach out to me. My email is listed below. But also, if you're looking to sponsor Cassandra Lunch or Data Engineers Lunch, you can reach out to me as well. We are part of Data Community DC. Data Community DC believes in building an inclusive environment, no matter your race, gender, or sexual orientation. Everyone is welcome, and we expect respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, happens under the umbrella of Data Wranglers DC. If you're interested in the various events and organizations that fall under the umbrella of Data Community DC, you can check out datacommunitydc.org and also their events as well. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra. And when we say Cassandra, that can mean open source, enterprise, managed, so ranging from Apache Cassandra, DataStax Enterprise, Skilla, Yugabyte, Cosmos DB, Amazon Keyspaces. I believe Amazon now has managed open source Cassandra, or it might be Azure. On top of that, also things that play well with Cassandra in the ecosystem. Oh, sorry, did someone say something?
Azure has managed instances for Apache Cassandra.
Okay, great. Thank you for the clarification. And I could throw in Avon and Instacluster in there as well. And things in the ecosystem that talk and play well with Cassandra. So Spark, Kafka, Kubernetes, Airflow, etc. So everything that is Cassandra, talks to Cassandra, or plays well with Cassandra, we cover here at Cassandra Lunch. So if anyone's new, feel free to drop a hi, hello in the chat. Group rules, if you have a question, ask it. This is meant to be community. So the more you share and the more you want to learn, feel free to have the ability, or feel free to feel comfortable to add to the conversation, always ask questions. And again, please do share what you know with us, but please do respect the speaker's preferences. They may prefer questions in the chat, or if they may prefer you just to speak up at a good stopping point. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some program and institutional sponsors. If anyone is looking for a job, or if they have any events that they would like to promote, you can drop them in the chat, either on YouTube or the Zoom chat. We'll get them ported over to both. DataStax ASTRA has a build-a-thon currently going on. The first month is wrapping up next week, but each month has a round of challenges. So if you missed the first month, you can always join the second or third month. And the top 3 winners of each round or each month qualify to present their ideas on demo day. And so there's prizes to be won on the monthly challenge as well as the demo day. So if you're interested, if you have any friends or coworkers that you want to partner with to help win some swags, win some cash prize, feel free to check out the link. I'll drop it in the YouTube and Zoom chats below as well. Anant is hiring. If you are interested in being a full-time or part-time data platform operator, engineer, architects, you can find out more at careers.anant.us. Upcoming Cassandra events, Cassandra lunches are every Thursday at noon Eastern. Again, we are looking at a more variable time slot, so that way we can cater to a live audience around the world. But again, all these videos are directly live streamed directly to YouTube. So if you do miss the event live, you can always stream it on YouTube or find it on a playlist, Cassandra Lunch or Data Engineers Lunch. You can find out more at our events page as well. Cassandra Lunch, all these videos, if you Google Cassandra Lunch on YouTube or just in Google in general, you'll be able to find the playlist. We have from Cassandra Lunch number 10 all the way up until today, Cassandra Lunch 92. So there's almost 80 plus videos on there. Cassandra.Link should be your #1 resource for all things Cassandra. Cassandra.Link is hand curated by the team here at Anant, with resources, videos, articles, anything that is Cassandra or plays well with Cassandra. So looking at the tags, we have at least 1,200 articles that are tagged with Cassandra, as well as articles that are tagged with Spark and Kafka. But again, these all relate under the umbrella of Cassandra. And with that, we'll go ahead and pass it over to our guest speaker for today, Rahul.
Hey, thanks, Arpan, for getting us started. Appreciate it. By the way, whoever is host or co-host, there may be a Zoom that was coming in with a random name, so I put them in the waiting room. Anyways, back to the actual topic we're talking about today. Today, we're going to follow up the talk that we did a few weeks ago on securing Apache Cassandra. And I'm going to review just high level, the context of security before we dive deeper into designing roles and permissions for users in Cassandra. It's not going to be like literally hands-on, but what you'll find is that actually doing roles and permissions is not about the technical ability, but it's really more about the design. And so that's what this is, about today. So make sure I can share my screen here. You should be able to see a Google Chrome window. Yes.
Yep.
Great. So because this is going to be part of the same series, I'm going to keep it generally the same cover slide. Securing Apache Cassandra, there's strategies and then there's tactics. The last talk we talked about was the overall strategy and specific tactics. And today we're going to actually dive into the tactics of roles and permissions. But everything is relative. When you get to roles and permissions, there's also a strategy for how to do roles and permissions. Security is a dance between convenience and protecting assets. In Cassandra, the most common dumb, idiotic mistake that people make is they start up Cassandra and they don't add authentication. Why? Because it's convenient. Because people can just connect to the application, do SQL/SH, do whatever they want. Well, you know what? There's really no way to protect that information if you don't have any users or roles, right? Or what they'll do is they'll enable authentication and they'll have Cassandra. It's basically the same. Anybody can guess Cassandra. That's a default password. So as we dive in today, you'll see that the inconvenience of planning out the security scheme is what actually allows us to protect assets at different levels, right? What good is the authentication and authorization technology if you don't have the authentication and authorization schemes? I didn't find a new quote. Next time we'll find a new security quote. Takes 20 years to build a reputation, a few minutes of a cyber incident to ruin it. I think I mentioned this last time. There are scans that scan the internet ports, IP ports for different database. Like 9042 is Cassandra. I forget the one for MySQL or for Mongo, but these are known ports. You can just Google them. And what hackers do is they scan those ports and they try to use the default username and password, right? So if you, at the very least, bring up Cassandra and you have Cassandra as a user and you change the password, that alone protects you from a great deal of hurt later on. We're obviously going to do a little bit better than that. So in platform security, right, there's network system data and application security. We talked about a lot of this in the first session. Today, we're going to talk about how authorization and authentication in Cassandra allow us to secure basically the connectivity between application and data. Right? We're not going to talk about network or system security today. We're not going to talk about encryption or backups. We're not going to talk about application level security and different ways to do that. We're just going to talk about how the application talks to the database, and then how maybe other users and processes can talk to the database. So network security, the assumption in what we're going to talk about today is the network security is sound, right? We're going to assume today that everybody in the team has done their job with the network and the firewalls, and then the only ports that are available for the application are the Cassandra client port, 9042. Or if we're using we're not going to worry about SSL. Let's say SSL is enabled, 9142 is available, and nobody uses Thrift anymore, so we're not going to talk about that today. We're not going to talk about JMX security because that's like system management security. That's not related to something we're going to get into that later and why that's important. And we're not going to talk about the SSH port because that's a system, that's a firewall port, and that's basically protecting the operating system. Right? We talked about how that's a different type of security for securing access to the operating system. In this case, we're assuming nobody has access to the actual Cassandra servers, the physical servers. We're assuming that the only way to talk to the Cassandra cluster is over the CQL port. And what that means is right here, right? We're not talking about any of this today. All we're talking about is we have an application and we have the cluster available and we have access to this database server with CQL 9142 or 9042. So how do we protect the assets in this database from the application user or from other users trying to talk to this? And the reason I mention application security here is that any decent database administrator from a Cassandra perspective is going to try to maximize the hardware for multiple tenants and for multiple applications, because that's just how Cassandra can work well. We don't have to have a different database for every new database, every new application, because Cassandra is like almost like an infrastructure, right? So when we think about Cassandra, we're thinking about a resource that could be shared amongst many different teams or tenants, and those teams could have multiple applications. Okay. So in Cassandra, how do we segment system users, developers, application administrators, application support users, application engineers? How do we segment those? Well, we think about roles, and we think about how the client, and the client being CQL/SH could be the client, right? That's just an application that talks to Cassandra using CQL/SH, or it could be an application that's using the Cassandra driver. Right? So in order to talk to the cluster, the client, CQL/SH, or your application has to authenticate, meaning be allowed in. And then once it's in, they're given authorization to certain things. So the main threat surfaces we're focusing on are CQL/SH and the CQL driver, or the Cassandra driver. I should really just call it Cassandra driver. Okay. And that's all over port 9142 or 9042. And I'll repeat this. We're going to assume this network is secure, the application is secure, system is secure, right? Where Cassandra is hosted, nobody can just randomly come in and do whatever they want. Right? So why do we need authentication or authorization? Well, we want to segregate or differentiate users for different types of access. That's what Cassandra allows us to do. out of the box. And it's a little confusing because they call everything a role, but we're going to put our own naming around it. There are lots of permissions and there are lots of resources. When you combine permissions with resources, we call that a permission scheme. And that permission scheme could be applied to a role, and that role could be assigned to a user. So first thing we need to understand is, I would say, the tooling. Actually, I'm gonna actually reorder that. I think the important thing is to understand well, I'm having a tough time because it's kind of like a chicken and egg. You have to know the technology to be able to design a scheme. So when we go about this, you'll see why I'm having this struggle to say what is more important, the scheme or the design of the authentication authorization, or is it actually like how to use it? At a high level, in Cassandra, you have these roles. Okay, and a role by default is not allowed to log in or have super user privileges by default. But if you give it login privileges, that basically becomes a user because then they can actually log in. I'll say it again. A role by default does not have super user privileges or login privileges. But if you give it login privileges, that role allows a real person to log in. And so that's how some people differentiate a user from a role. You can have a user that basically logs in and has super user privileges. That's what Cassandra is. It has all the permissions in everything by default, right? You could also make a user for Rahul and say they're a user or super user and they can log in. So where does this idea of permission schemes come in relationship to like users or groups of users? Well, what we do is we define, let's say, a user as somebody that's going to log in with the username and password, and we define a role as a collection of permissions. And the only thing that we give a quote user that's going to log in is the ability to log in. And we don't want anybody except for like the super admin to have super user privileges. So that's how we differentiate set of permissions. We're going to say that's a role, and a user is basically a role that can log in. When you get started, just add a few more users like your super admin user and make them super admin, give your own password that's not Cassandra, and then basically disable the Cassandra user. That's the first thing anybody should do. So, if you're creative, you're going to make your super user, name unique to your application or to your company. And basically people will have a hard time even, guessing what the username is. Now, permission should be segmented by need. And we're not going to talk about LDAP or Kerberos, meaning internal versus external today, but the same things we talk about from a authorization perspective could be used with LDAP or Kerberos, because LDAP and Kerberos are basically responsible for the authentication, meaning getting into the cluster. These authorization schemes can be used with whatever, whoever logs in, right? So you can make a role in Cassandra and then assign that role to somebody that's authenticated via LDAP or Kerberos. That's a more advanced topic. So I just gave you a quick glimpse of the tooling, and now we're going to go into the design, and then we're going to get back into the tooling. So here's one example of a role that we create that is different from Cassandra, that's going to be our super admin. We're going to call it super_admin. We're going to create a role. And in this Excel file or Google spreadsheet, what I'm doing is I'm actually taking all the permissions that are potentially available across resources or objects, right? And saying this user, and this is just a planning tool, right? Maybe we'll give it away as a download later on down the line, okay? Where we're going to say super admin, we're going to give it all permissions, meaning grant on functions, key spaces, roles, authentication schemes. And if they have access to these, they basically have access to them. But you can actually say all permissions. You don't have to say alter, authorize, create, blah, blah, blah. You can just say all permissions. You probably only need to do this once because you're going to have one super admin. You don't need, well, you could have one super admin and then you could have people given that super admin role and they would have their own login, right? So you can have an audit, like who actually deleted this database? Super admin deleted it. Well, no, that doesn't make sense, right? When you make a role, you're going to make users with logins that are then assigned that role. So then you could actually audit who deleted what, who did what, if that happens. Next common role, we would say is a read-only role that we're making to be specific to a particular application. So in this case, there's a tenant, they have an application, and I just named it tenant1_app1_RO for read-only. So in this case, what you'll notice is that I didn't decide to give them all permissions to all of these things, right? I just decided to give them describe, execute, and select permissions on functions in tenant1_app1 key space, because that would be a key space we would put stuff into. And then same thing on key space tenant1_app1. You could go one level deeper if you wanted to and have a read-only user down to the table level. So for example, if you had a tenant that had a bunch of tables in one key space, you could have a read-only for table 1 defined. It just depends on the need of the organization and application. But you need to give it the select and describe on authentication schemes because, well, your user can't really do stuff if it can't read the authentication engine, basically. So at the very least, you got to be able to describe and read from it. That's why you got to have this. And then, of course, if you're using functions, a lot of people don't use functions, but if you're using functions, you got to give them functions and then the key space. And if you wanted to, you could say the table. I included this in the orange dotted block to show that in DataStax, which has other things going on, like Spark, that if you want it, or let's say always on SQL, which is also part of Spark, in order for users to be able to submit Spark jobs, they need resources, access to other, so they need permissions to other resources. And we're not going to talk about this today, but just to show you, you can use the same general design to design an authentication authorization scheme for DataStax as well. And that further, emphasizes that Cassandra is a part of DataStax. DataStax is not Cassandra. DataStax is a bunch of other stuff. Read-write role, right? What good is an application if it can't put data in there? So same thing, tenant1app1, but we're going to call it _RW. And, or did I? Yeah, here we go. So we're going to give it all permissions on the functions and the key space because we kind of need it to do all this other stuff in it. And for authentication, we just need to give it execute permissions. And as we continue, the main thing I'm trying to get across today is that the technology itself is very simple. You say, here's a role, we're going to call it team manager, we're given a password. And here's a role called system admin. And I want to grant this system admin role to the team manager. And we can give specific permissions to either the team manager or to the sysadmin role. And you can have another user, let's say Kyle, and say, grant team manager role to Kyle. And then Kyle has what the team manager has in terms of permissions. And then that obviously gets everything that the sysadmin has. So you can have different levels of this. So as you can see, like, if you don't have this stuff planned out, you can't really do a good job in securing Cassandra. You have to put in the time to really understand who's going to be using it, why are they going to use it. So make a spreadsheet. You don't have to use our schema here, right? You can make your own. And then segment your system-wide roles. So super admin, what do they need to be able to do? DevOps, what do they need to be able to do? Application support for the whole system, what do they need to be able to do? Then we get to the tenant, or like a group of applications in like a team or a department. Well, we can have tenant admins, we can have tenant DevOps to be able to do stuff in that particular key space, for example. There's actually, and we'll show you the Cassandra documentation, but there's now even a way to restrict access to a data center. So if you have a key space that's only available in a data center and you allow only access to a particular data center, they won't be able to see anything that's in another key space. And then, of course, we scroll down to the application itself. We're talking about a little bit more granularity here. We're talking about, is there a developer in that application team? What do they need to be able to do? Is there an application support where they need to do read only for a certain set of tables, for example? Or in general, is there an application, meaning that like the Node.js client or the C# client, right? That's going to be talking to Cassandra. Do we want to segment that service user from? Yes, we do actually, right? We want the user that's actually doing the read only for a certain set of data from an application perspective. We want to have that in a different role than, let's say, an actual person, because that's really how we can granularly say, well, the application support person can look at more things, but the application itself can only look at certain things. So when we look at the Cassandra documentation, where this goes into great detail, right? I didn't want to reinvent the wheel here. It tells you how to do these things, like create a new role. Well, great. Now, if you give it a password and a login, that becomes like a user, right? They can actually log in. You give them super user. You can give a bunch of options. I don't have any custom options we're talking about today, but here's, for example, how you can say this role, Alice, has access to data centers 1 and 3. Here's a person that has access to all data centers. So when we get down to granting, right, you can say grant this role to this role here. Well, the role, if it doesn't have any permissions, doesn't mean anything. So users, basically, it's like users are we use roles, but it's just an older syntax, right? So that's why they've like grandfathered it in. They still have a cool user, but normally if you're going to do stuff, just use roles. Any questions here? Okay. So permissions, we looked at that earlier. There's a hierarchy, right? Key spaces, key space in a table. Functions, all functions in a key space, and a particular function. You can say just to be able to run a particular function. All roles, or just a particular role. And then these are for GMX, we're not going to talk about today, but it's also available. This is very similar to other databases that are like Postgres or MySQL. It's very similar. Now, resources, as they have hierarchy, right? You can create permissions to all these things. All key spaces, a particular key space, all functions, particular table, right? So you can see how just a handful of permissions and a hierarchy of resources and objects without even specific ones could end up with so many combinations and permutations of permissions. And this is how you grant permission, right? Grant execute on this function to this role. So as I was mentioning, certain system key spaces, you need to have read or select permissions on them. Otherwise, you can't actually read the data. So to come back full circle, as I was saying, like I'm struggling to explain basically what's important, understanding the tooling or how to design the system. Well, I would recommend start off with add your own user, give them super and log in, have a password that's separate from Cassandra, remove the Cassandra user, or at least disable it. And that's a good start, right? Make a super admin that can do most of your stuff. You could even have a super admin just for an application and give them access to just their key space. And then if you need to go down a little bit more granular, like read only, read write, you can go do that down to that level. But the work is actually, I think, in the design. This stuff is fairly simple. You can go Google this stuff and copy and paste it from the documentation, but if you don't have a good design, it won't really matter what you copy and paste. All the resources, like this is the really good one. The other resource is the one on DataStax's site, which is a little bit more illustrative. And that's generally the case. So let's see. Here we go. Yeah. So they have, a few more examples. They have some pictures, although I think there's a better link, which I also have linked here. Bring that up. Here we go. Yeah, so actually, I actually used these examples earlier, so maybe I was looking at the same thing. Documentation's there. If you are, having trouble with this, there's a lot of resources also in Cassandra.Link. Just look for Cassandra Security. But that's it for today. And the next time we'll pick another topic out of the whole, platform security landscape. Maybe we'll do SSL or we'll do JMX. I'm not sure, but stay tuned. And that's it. Arpan, back to you.
Yep, sorry. I realized I wasn't sharing my camera when I did the intro. I was focused on grabbing some good music. No, I had a question. Since you mentioned it kind of briefly, that the structure, or at least the commands to create users and permissions is similar to SQL. So say if you're in the progress of migrating from SQL to NoSQL, you're taking that next step in your enterprise level data. Is there like an easy way, or would you recommend doing like the matrix so that way you're reevaluating the current users and roles you already have and then creating them through the process? Or is there like a tool out there that you can like export a schema of users and then import that into potentially CQL?
I'm not aware of a tool that can do like an export of roles, except for the fact that like I'm pretty sure like certain describe commands will give you like list roles or whatever will give you that information, but nothing that's going to map it. So like any transformation, you take what's there, you take an inventory of it, what's there now. And as we've talked about in the past, when we transform from a monolithic system to a globally distributed system, in that transformation, things are generally decomposed into different things. So more than likely, things are going to be broken up anyways. So I would say just take an inventory of it in some form or spreadsheet or whatever, and then you'll see that it's easy to just make a copy of it and say, oh, we don't have a database anymore, we have a key space, so we're going to put key space here. And the rest of the table level stuff is almost identical. So maybe some of that could be reused. But yeah, there's no push button thing that's going to copy your authentication scheme and drop it in.
Yeah, cool. Yeah, it was just something that kind of had the thought, maybe there's something someone did out there. Maybe there's something out there, but interesting to see, because obviously like there's a lot of things you have to take into account when you do migrations. Generally, we on these talks or data engineers lunches, we've mainly focused on the data transfer aspect, not maybe necessarily the security aspects as much. So I think it's potentially something we could backlog for a future talk as well. And so there's another question in the chat from Isaac. Does Cassandra only support LDAP or Kerberos, or does it support other external authentication like Active Directory, for example?
So Active Directory also supports LDAP. So if you're using the LDAP connector, you can use Active Directory. So in Cassandra, the internal authentication, internal authenticator is the default one. It comes with that. To use in open source Cassandra, LDAP or Kerberos, you have to use a plugin from Instacluster. They have an LDAP one and they have a Kerberos one. If you use DataStax, it comes with the internal, and then they have what's called a DSC authenticator that allows it to do the stuff that I was explaining, like the DSC resource manager and things like that. And then they have an LDAP connector, and then they have a Kerberos connector. And then I have seen companies leverage, let's say, Okta to authenticate users into the, both the application side, but also from like a system side. And there's stuff in the DataStax world called proxy users, which again, we don't have time to discuss today, but Active Directory, Kerberos, internal are the most common ones I've seen. But you have to look outside of Cassandra to use it if you're using open source Cassandra, or you would just DataStax. I hope that answers your question.
Looks like another question in the chat. From a design perspective, what would you recommend doing to protect against super admin users whose credentials are stolen or compromised through other methods?
So super admins, never need to do things from outside the cluster, for example, right? So even if the credentials are stolen, if the network is secure, if the system is secure, that password won't do you any good because you can't even access it, right? So then more than likely, the question is really, what happens if an insider threat finds a super user password? How to guard against that? So again, these are policies that companies put in place. If it's a user, users don't share passwords. If it's a service or an application, those what's called non-technical accounts. Sorry, there's non-technical personal accounts and then there's technical accounts. If it's a technical account, then a technical account, basically the credentials should be stored in a vault, like HashiCorp Vault, and those passwords are rotated. And when they're rotated, an application that has access to that vault can read that password at runtime or deploy time and do what it needs to. So your application itself doesn't have the password. The passwords are not in configuration. They're in vault or console. You can use console. And so your application first authenticates to the vault with a key or some other way, some other config. Then it gets that information and then it does its thing. So same thing with a super admin password. We can put that in the vault and only certain people can have access to that vault. So if a password is compromised, an automated process would rotate that password, but it would first change the password and then it would rotate it. And so the person who has access to the vault then has access to the password, which that means that then they have access to the system. Does that answer your question?
One quick follow-up when you're referring, maybe it's HashiCorp specific, the vault specific, but when you say rotate, does that include changing the password, or like is it a process that changes it and rotates it, or is it just rotating and then changing is a different process?
So it's system specific. In this particular case, when we say rotate the password, it means generate a new password, change it in Cassandra, update the vault with the rotated password. That process would be automated by whoever the security team is in conjunction with the DBA team. Nobody does this stuff manually. Every now and then you have to do it manually, but generally it's automated.
Got it. Thanks. And I guess maybe you'll cover this in a different talk, but since it came up, is there maybe a specific reason you would choose to use LDAP over Kerberos, or is it kind of a preference at that point?
Oh, that's a good question. Those are decisions usually left to the CIO of the organization. And why one organization was used one or the other, they've been using it all along. So they're not going to switch, right? But they're using Active Directory, so you have to use LDAP because Active Directory has an implementation of LDAP. So that's one way to answer that question. It just comes as a decision from before. It's like a question like, why would you use Azure versus Google versus Amazon. Client has it, that's why you use it. But from a technical perspective, Kerberos has been around, LDAP has been around, and so even as far back to like when they were first out, people would ask the same question: why would you use one or the other? And that's almost like a religious debate between why would you use PHP versus Ruby on Rails, which I both hate. They're total pieces of shit, but I don't know.
Got it. Yeah. Thanks for the clarification. Okay. If anyone has any more questions, feel free to drop them in the Zoom chat or YouTube chat, and we will get them answered.
Awesome.
Rahul, following up on the compromised credentials question. So I think you kind of answered really clearly from like once you detect the like invasion or whatever, what systems or designs can you put into place to sort of do the detection so that you know you need to start that process of cycling out the passwords?
One is audit, right? Nobody should be really logging in with superadmin. End of story, right? That's a break glass type of user, because you would have admins or DevOps or deployer roles for regular day-to-day things. That's one way that you have as a policy. You have an audit system that basically checks to see as superadmin logged in, right? And if somebody who has access to that superadmin role didn't log in, they'd be like, hey, what's going on? Right, so that's a out of ordinary process to log in as superadmin. Even the creation of users would be done through like a service user that has access to create. So there's superadmin, and then there's what we say limited administrator. Like a database administrator would be different from a super administrator. Another way to kind of look for patterns, and this is kind of getting into the realm of like threat detection of like, what's a threat? At each surface of the system, there are different threat patterns. So how do you know if somebody stole your backup? Well, that's a different system, right? You put the backup onto S3. Did anybody access S3? In the realm of Cassandra, audit trail basically can detect who logged in, what query did they run. Were there any drop statements? Normally, we're not doing drop table, you know, if a system is in operation, we're not dropping tables, right? We're doing selects, inserts, maybe deletes. So at each interaction surface, there are ways to define what could be a non like an abnormal pattern, basically. One thing is not necessarily like an intentional threat, but it's the new person in the team problem that doesn't understand Cassandra, and so they do a select star from a table that works fine in their laptop, and by chance they're in the middle of a crazy situation. They're the only person that can help out, so they're put into a production issue, and they do a select star with allow filtering because that's all they know, right? So normally people would not be doing allow filtering. So how do you guard against that? Well, newer versions of, let's say, DataStax has like guardrails to say, hey, this is not allowed, right? Or when you run it, there's a warning and that gets put into the log. But the best way I can explain is that it is really what is and what is not a threat. Because what could be a threat in one organization and one type of data set would be a normal course of operation in another one.
Thanks. That clarified it for me. Thank you.
Yeah, security is like, it's like an art and a science. It's like, that's why I was having a difficult time saying, like, is it more important to know the grant commands, or is it more important to know how to design it? Well, you kind of have to know both, right? You got to know what is possible with the technology, but then you also need to know what is the right and wrong use of that technology in a particular context. Any other questions? Oh, sorry. Yeah, go ahead.
All right, doesn't look like there's any other questions from the Zoom chat or the YouTube chat, so we'll go ahead and wrap up for today. Thank you everyone for joining us for Cassandra Lunch. Thank you, Rahul, for giving a great talk. We look forward to the next part in the series, and we will see everyone on Monday.